Good afternoon, everyone. We have still people joining, so we're going to wait for a few more minutes and we're going to start shortly. All right. Good afternoon again, everyone. Thank you for joining for our second consecutive webinar. It's going to be recorded, so a lot of people who is going to be a little bit late, they will watch the recording afterwards. So today we're going to focus on a topic called releasing mobile apps, which is a very sensitive topic nowadays since a lot of mobile applications have been developed and a lot of people switch from the web to the mobile. And specifically, today we have a guest, Nathan Krishnan from HeadSpin, who happens to be our sponsor for our webinars. And he will elaborate on the topic how to understand network performance bottleneck and test your mobile apps hardware features. So before I'm going to pass the presentation to Nathan, I would like to launch the poll so everyone on the screen will see the question pop up. Please, take a few seconds and answer that. So give me 1 second. And here we go. So take your time, answer this question. It's a really simple question. If you ever use cloud device farm in the past. Perfect. So let me close the poll and move on, switch the screen presentation towards Nathan. Here we go. Nathan, you are online.
Perfect. Excellent. Thanks, Igor. And hi, everyone. It's a pleasure to virtually meet you. So for today, I wanted to talk about a couple of things. So before I even jump into talking about network performance, use cases, and in general, testing your apps on a distributed global device cloud, I wanted to give a couple of moments to give background on HeadSpin and what we do. So that said, I'll go into presenter mode here. So that's it. I just had a few slides.
I'm sorry to interrupt you. I just want to let you know we see your screen, everything is good. And everyone, please feel free to ask questions. There is a question panel. You can collapse that in the GoToWebinar settings and write your questions during the Nathan presentation. And at the end, we're going to leave a few minutes to answer your questions. So don't hesitate. Sorry, Nathan, for interrupting you.
Oh, it's all good. No problem at all. And thanks for noting that. I'm glad that my screen is visible. So that said, I just wanted to start off with talking about the thesis of what we're trying to accomplish as a company. At HeadSpin, our primary goal is to allow you as the developer or tester to experience your mobile application the way that your users in the field are using it. So that said, we built out a distributed global device cloud that has real devices with real SIM cards in these real locations. So that said, the core of what we're trying to accomplish is building a set of tools that can be used for both pre and post launch to help test these features that you're working on and find and fix bugs in your application. So that said, at this point we have over 23,000 real devices on real carrier networks globally. And also in terms of being able to allow people to see the true network performance of their applications, we actually built out an AI-based issue detection engine using Google's TensorFlow neural network library. And I'll demonstrate how that capability can be used in order to find and fix issues regarding to network performance at runtime. Yeah, in a nutshell here, why we're different is that I'll touch upon a couple of things here. So one is that in our platform, there's no SDK required. So this is an incredible, important driving principle in what we build at HeadSpin, just because end of the day, if you start to add third-party SDKs to collect analytics and performance measurements, and inevitably, one is that when you start to add these third-party SDKs, you're adding divergent logic to your application. So now it's another dependency that adds file size bloat to your final APK or IPA file. But also too is that inevitably, like with anything third-party code related, when things go wrong and an app crashes, now it becomes another sort of exercise, if you will, in figuring out why the app crashed. Was it related to your logic, or was it because of third-party dependencies or SDKs? The second is that fundamentally in our platform, all devices, they're not rooted or jailbroken. So this is very important because your end users are most likely not going to be using a rooted or jailbroken phone. So therefore, that's once again another sort of core pillar in our platform in the sense that these are stock phones. And then the last thing that I want to note here is that because Google and Apple are customers and partners of ours, we're able to offer zero-day support for OSs. So for instance, iOS 12 was formally announced not too long ago at WWDC, and a couple of weeks prior to that at Google I/O, Android P, and some of the new features in the operating system were highlighted. So that said, I just wanted to sort of throw this up here just to give a shape of essentially our deployment. So at this point, we have pretty vast reach, and thanks in part to the help from the Google App Store team and the iOS App Store team for the analytics they've been able to provide us in terms of what are popular devices in a given location, and also in general the top locations in terms of downloads from the respective app stores. So that's what I wanted to talk about use cases. So when you have the ability to test on real devices, on real carrier networks, there's a lot of really interesting things that you can do that sort of open up your aperture for testing, and therefore allow you to test things that you traditionally couldn't do in a simulator or emulator. So the first one, which is always a challenge for apps that have an international focus, or as an app developer trying to expand into emerging countries, is being able to localize correctly. So this is actually a real screenshot from the TED mobile app for iOS from actually just 2 years back. And I wanted to show this out there in the sense that even sort of high profile app launches, these type of blunders can still happen in the sense that as you can see with the three dots, there wasn't much localization testing in German here. So as a result, the text got clipped off. This is something that if you have the ability to test on a real device, like on a real iPhone, let's say in Hamburg, Germany, you would have the ability to see that this text would get cut off, and it'd be a very easy fix in Xcode just to increase the number of lines that either the text can span, or to simply just change the font size, like for this particular for this language set. The second, which I'll go into a couple of real examples towards the end of these slides in the HeadSpin platform, is being able to capture network performance. So, as we all know, when it comes to mobile, like your performance is very, very dependent on the network performance that the user has. So when it comes down to it, the carrier network they're on can really determine and sway the user perception of what's a fluid experience. So fundamentally in our platform, this was a really heavy focus for us when the company was just started. And essentially, and I'll sort of go into like an actual example soon, is essentially in the platform, we allow you to capture the network traffic, and then we feed it into our AI engine. And then based on the shape of the traffic, we give you recommendations on what were areas of poor user performance, and then furthermore, how do you sort of fix the issue, like once you've identified the issue. So ultimately, giving you clarity on being able to know what the performance is like on a real carrier network. And then third, also because these are real devices, being able to test out hardware features. So for instance, if you're working on an app that has a map view component, whether you're using Google Maps, Apple Maps, or a third-party map SDK such as Mapbox, like being able to actually test what that experience is like with the assisted GPS hardware module in the phone, as just one example. Second is that we've also built a capability such you have the ability to pipe your input audio. So for instance, as an example from the MacBook Pro that I'm presenting from to the remote device to test voice actions or even third-party like triggers for instance, if you're integrating with the Amazon Alexa SDK and being able to like do a voice search or a voice query. And when it comes down to it, being able to test these hardware features, especially if this is a core functionality of your application, it's really important to do this on real devices instead of stubbing data, just because it's easy to mock or stub, but like harder to sort of actually test and see what that feedback is like if you're not using real devices. And then lastly, for your app, especially, this is a huge thing that we see amongst our gaming customers, is being able to test carrier-specific features. So for instance, there are a lot of third-party servers to do in-app purchasing and carrier billing and bundling. So for instance, a good example is PandaPop in the sense that in this app, there's a lot of, especially like in order to gain certain amenities in the app, there's a lot of prompts for the user to purchase in-app items, such as in this case, buying more lives. So essentially, as part of this app, they actually have this carrier billing flow where such that like based on the carrier network that the phone's on and the phone's phone number, instead of having the user to like use Apple Pay, Google Pay, or even take out their credit card or use some sort of third-party service such as Stripe, for example. Like essentially they've tied it in such that like once a user clicks on items that they want to pay, their carriers such as T-Mobile, Sprint, AT&T, etc., it'll actually appear on that user's billing for the month. So when you want to test these type of flows that have carrier integration, in this just example here for in-app purchases, once again, it's just very important to actually have a device on a carrier network. So that said, I wanted to showcase two things in the webinar that will help for testing and also figuring out what your performance bottlenecks are. The first feature in our platform is remote control. So essentially, because this is a global distributed device cloud and these phones are located in different geographies, we essentially created like a web application using WebRTC to allow you to remotely control, as if it was a VDI experience, if you will, so to be able to actually control these devices. And this is great for especially manual testing of user flows. And the second is performance session. So essentially, at app runtime, being able to collect all of the network traffic that's occurring and getting smart recommendations on problems that have been identified, and then essentially recommendations on how you can fix these issues based on our AI-based issue detection engine. And then some of the really important data and metrics, and I'm giving sort of an abridged list here that are really important from a network perspective, is knowing the network protocol details, knowing the connection establishment times, and then of course from the API server perspective, knowing the performance of your API server, some of the metrics regarding what's happening in terms of the content types, error codes, etc. And then, of course, if you're using like a CDN such as Akamai, like just getting metrics back on the CDN, because CDNs are great, but at the same time, for optimal performance, they have to be configured for what you're trying to accomplish. And then, lastly, especially if you have third-party SDKs integrated, being able to see what's happening at a network level really helps you figure out what are the outbound requests that this third-party SDK is making. You know, like, are these requests reasonable to make? Are there permissions that could be changed in your app to either be more restrictive or permissive to allow the third-party SDK to accomplish what it's trying to do? And then lastly, especially when talking with about network performance and networks in general, I'd be remiss not to mention network security. In the case, for example, if the connection was HTTP or HTTPS. So very important, especially from a security perspective, especially if you're rolling out your own authentication flow and not using a third-party service to do authentication. So that said, I wanted to actually jump into just a couple of live examples here. So the first thing is I wanted to give you a sense of what that remote control experience is like. For this webinar, I've actually created a demonstration pool just to showcase some of the functionality here. So essentially, once you log into the platform for the first time, you'll be presented with all the geographies that are in your account. And they'll be arranged by country. So in this case, I picked a pool of Latin America, countries in Latin America, and also in North America. So from here, what I can do is that I can actually go ahead and pick a geography. So for example, I'll go ahead and pick just Brazil. And then from here, I have the ability to see all the devices in this pool. And because these are real devices on real carrier networks, as you can see, we can see the carrier here, and we also have the phone numbers here as well in the device notes. Just to sort of continue this further, I'll go ahead and pick this Moto E2 in Brazil on the Vivo network. So right now, it's instantiating that remote control session into the phone. So at this point, all mouse clicks that, from my computer will get translated into touch events on the phone. So for instance, I have the ability to, for instance, open up the app launcher, scroll through this, and then from there, pick the app that I wanted to test. So for example, if I wanted to test what the experience is like in Brazil, using, let's say, for instance, using Snapchat, I can go ahead and I can just launch Snapchat. And then at this point too, during this session, as you can see, this is what cold launch looks like for Snapchat, in Brazil for this phone. And at this point, one thing to note here is that we've also built out helper panels for interacting with the device for these manual sort of use cases. In the case that if I wanted to, if I had a dev build of my, let's say, APK, because I've selected the Android device, I could go ahead and drag and drop it in here, and it'll automatically install on the phone. That said, we've built out helper shortcuts for common things that you'd want to do, such as, for instance, go to the App Store, download the public build of your application. For instance, go into settings, change any configurations or sort of any preferences of your liking, and also just direct access to ADB shell. So for instance, if I wanted to at launch take a look at all my activities, I could do like a dump sys to retrieve that back. And then furthermore, what's great is that if I go back into host, is that I can actually put these devices side by side. So for example, what I'll do is that I'll actually take, let's see, some devices in Mountain View, and I'll launch a Nexus 5X. And what's great about this is that I have the ability to actually put these devices side by side. So what I'll do is that I'll actually put the device in Brazil that we were using earlier, and I'll put it to the left of the Nexus 5X here. And what's great about this is that at this point now, I can actually test on both of these phones simultaneously. So for instance, I could launch eBay here in Mountain View and launch like for instance, if I had the eBay app installed here as well. Like this gives me the ability to test what the app experience is like on different pixel densities on these two divergent phones, but both running Android. And I'll go ahead and exit out of here so we can just go back to full screen into the this device into Sao Paulo, Brazil. What's also like what you can do within this remote session is that I have the ability to also enable performance sessions. So all I have to do is simply, for example, click on this movie icon, and it'll automatically start initializing the performance session and start capturing any sort of network traffic from this point onward. So essentially, like once this finalizes, all like network traffic will be captured. So to give you a sort of a example here, we can just do live together. Is that let's say that we work at Airbnb and we've been tasked to improve the performance of their Android mobile app. So at this point, I have performance session enabled. I can go ahead and select the Airbnb app. So at this point, like we have the ability to, like for instance, we wanted to test this sort of login auth flow. So what I'll do is that I'll go ahead, I'll continue, I'll test with my Google account. Essentially from here, oh, interesting. So this is actually like very interesting actually to see. So as we can see, the Airbnb app has stopped. So this actually and caused a sort of a force quit there. So what we can do at this point is that we can go ahead and actually stop the performance session. We can stop this recording and actually navigate to the performance session view. And this is the quick test that we did right now. And we can actually jump into that and see all the network information just from that quick session. What's great about this is that everything is color coded in the sense that we're presented with this waterfall view that is very akin to essentially the Google Chrome developer tools. So it's sort of very familiar in the case of sort of like other existing tools that have been built, such as the Chrome debugger, to analyze this network traffic. And as you can see, the AI-based issue detection issues have been bubbled up to the left-hand column. So that said, I actually wanted to go through like a couple of runs that I've done for two big brands and go through some of the findings there that might help you like in terms of when you're taking a look at the network performance of your application and sort of reducing and fixing problems at that level. So the first one that I wanted to show it was a run that I did with collaboration with Bed Bath & Beyond. So like it's a very big store that sells home goods and some furniture as well. So essentially from this run, what the team was trying to figure out was that they were getting several poor reviews on the App Store when users were going into the clicking on items and also making search queries. And on top of it too, some users were complaining that it took a long time for this app to load on cold launch. So essentially, to answer the first question that I brought up was in our vernacular, we call this area of low page content. So areas where there's very little user interaction on the screen. So if I go ahead and just click on this panel, as you can see, our AI engine has detected these issues with the red bars. So if I hover over a red bar, so for instance, this was actually the cold launch of the Bed Bath & Beyond app. As you can see, it took nearly 12 seconds for this to load and get to and load the first default page. So as you can imagine, that's a very long load time, and certainly like an area for sort of for exploration, just because on average, I mean, most consumer apps will load anywhere between 6 to 8 seconds, and that's on average. And of course, like the apps that sort of the companies that are sort of rock stars and optimize will beat that and be even quicker. So for instance, the Amazon Prime app on average from numerous tests I've done on different Android devices in North America will take anywhere from 3 to 4 seconds on cold launch. So that said, it's identified these areas of low page counts. And so as we saw from the cold launch, but also too spinners. So for instance, this ties back into the first thing I noted, where users were complaining on this app about how the item detail views would take a long time to load. Like in this case, it was 3.64 seconds before it would actually load that particular item page. And then the same that can be shown before getting into the actual item thumbnail view. So from here, in terms of common things that we've seen that have been bottlenecks for a lot of consumer apps and apps that we've seen in the wild in the market are essentially slow server responses from the server side. So that said, like one of the most canonical sort of measurements in this field is time to first byte. Essentially, this is a metric that basically gives you the time that the first byte of data from an HTTP request was received by the client. So that said, this measurement includes both the socket connection time and the time that it took to actually receive the HTTP request on the client side. So that said, like one thing that we see more often than not is actually poor placement of the API servers and CDNs. So there's two things to note here. One is actual physical location, because physical location does dictate the hop time that for how many hops it takes to reach the server from where the client has initiated their request. So the first thing to note is essentially, and the first part I would say to be introspective about is like where these components are physically located. In the sense, if you're using, for instance, Amazon Web Services, and you have like a sort of a load balancer for your API server, the first question to ask yourself is that, like, where are my requests being routed? Are they like, if a request is being made in a certain geography, is it being routed to, like US East, US West, etc. And that said, in our platform, the impact time for each request shown in green will be will give you time to first byte. And then on top of it too, like once we click on a request, in this case it was a post request for the shopping cart, we have the ability to take a look at the request headers the request the client has made to the server, as well as what the response from the server. And this actually brings me to a second thing in terms of what's important for sort of improving and sort of debugging these network bottlenecks. So what's really important is your cache control. So this is something that that I've noticed time and time again that has been a sort of an area for sort of an area for improvement for a lot of applications. So that said, to sort of take a sort of step back here, like a lot of app assets that you might have, such as images or videos, if your app has videos. Like a lot of network architects will use CDNs for the delivery of these assets. And what the cache control is that it provides like a numeric value on how long this should last before the frequency of it becomes not cached. So in summary here, if an asset doesn't change often, it's better to set a higher value here. And more often than not, I've seen developers set low values for assets, even though they don't change frequently. Here's an example. So in the context for Bed Bath and Beyond, for a retail application, one of the features in their application is a deal of the day. So like in this sort of scenario, the developer would be better off setting the cache control header to 1 day, so that the entire day of the deal, users don't have to go to the origin to fetch the deal's images. But on the other hand, for product images, it'd be good to have higher values, such as a year longer, because especially if these products don't tend to change frequently. So that said, those are a couple of things that I wanted to highlight here with Bed Bath and Beyond. And then to sort of continue this retail example, I wanted to actually switch over and give an actual example that we did for the Walmart consumer app in North America. So essentially, like Walmart, they were trying to tackle a couple of things here. But one in particular from this run that I wanted to show sort of two things here. One, like once again, like areas of low page content, because for e-commerce apps in particular, the shopping cart is the money making feature, and if all else, that needs to be performant. So for instance, if I scroll here to the right, as you can see, when we went through with the Walmart team, like a user flow such as we add an item to the cart and check out and process it. As you can see, before it even gets to the payment portion, there was a 4-second delay before that happened. And as you can imagine, like this has to be performant, because if the shopping cart takes too long, then users may not even finish that transaction, and that can cause issues. So that said, so this was an area for exploration that we did with Walmart, and essentially some of the findings that we found were. And I picked this one because it was sort of nice and clean in the sense that there was two, but there was actually numerous to choose from here. Is that another thing to keep in mind when trying to fine tune your network performance are duplicate messages. So the app either receiving identical copies of the resources from the request, or your app actually sending out multiple of the same GET requests, which we've seen from doing numerous tests on the Walmart consumer app in Android back in March. So for example, what we're looking at here is that the square is the reference call. So this is the first network call made, and then the yellow circle is the duplicate. So if we take a look at here, what we notice is that in this item detail view, we actually saw the same GET request happen twice. So for instance, what's great about like being able to dig into this and know the network request is that from a developer and test perspective, I can actually take a look and see what that JSON payload is. So for instance, I can take a look at, in this case, it's showing it has the data that was used to construct that view. I can actually take a look, first of all, see, is this the data that I'm getting back, is this even correct? And then second, like take a look at the response headers from the server, see if these settings match what my expectations should be from how I configured how I thought I configured the CDN. And then lastly, too, take a look at any offending calls. So for instance, this is the same GET request that was made. So this is a duplicate request. So there's a couple of things that could be the culprit here. But the first sort of point of reference is at this point, you know what the request is made. So if you have the source code, you can actually at that point take a look at the corresponding function that invoked this call in the cart, and take a look at if the callbacks are being handled correctly. Because what I've seen often is, especially for in this case for Walmart, for apps that try to create their own internal networking libraries and don't use either popular ones or just sort of system wrappers around like low level network calls, is that so once again, the case when companies or developers try to sort of creatively create their own these network libraries, is that oftentimes one common thing I've seen is that you'll see multiple requests being made, but the callback not being handled correctly. So essentially what will happen is that once the response comes back and one callback has finished, you'll see other requests happen in the background, and then eventually gracefully time out. But however, and even though the timeout is graceful, these network requests are they attribute in aggregate to a longer load before like a certain view was populated or an image appeared. So that's certainly a really important point of contention to take a look at. And that said, because the platform provides the full fire hose of what's happening at a network level, we have the ability to dig in a little bit deeper, in the sense that, for instance, if we wanted to take a look at the reuse of TCP connections, we have the ability to do so. And once again, square is the initial connection, and the circles are subsequent connections. And in the case for this view, essentially, it's color coded to show you that, for instance, for this particular segment of requests, it could have all happened through one TCP connection. And there's a lot of sort of prerequisite knowledge to share here. But suffice to say, this is the connection reuse is important, just because creating new TCP connections is expensive. And that said, there's two last things that I wanted to note about, from looking at network performance. Lastly, is that like being able to take a look at all the outbound domains that your app was calling out to is like very helpful, especially for third-party SDKs, and in particular, some interesting things that I've seen with AdMob or other ad SDKs, in the sense that some of the outbound hosts that these especially non sort of first tier app ad SDKs go out to are definitely a bit suspicious in terms of those outbound domains. So being able to take a look at what's happening there is super helpful in terms of sort of triaging of basically what's happening in terms of the third-party SDKs you're using and what services they're calling out to. And then lastly as well, I just wanted to show very briefly our burst UI. So primarily for walking through some of the examples, we've been showing the nitty-gritty of the network calls, and we've been looking at it from the waterfall UI. But the one other thing to note is that I wanted to note is our burst UI. So essentially, the waterfall UI is giving the full fire hose of what's happening, and the burst UI has access to the same data, but it's visualizing in a different way to answer the question of, given that my app has multiple issues, where should I start first? So the idea here is that you want to start with the fattest histogram, because that represents the biggest impact time. Once you jump into that histogram, you'll see what we call the impact curve. So each of these bubbles, if you will, on the curve represent like an issue that impacted performance, and these performance once again from the same data, from the same machine learning model, but now just presented in card view. So at this point, for example, if I wanted to take a look at this slow TLS connection, I have the ability to click on the card. I'm given back explanation of what the issue is, and then also how to fix it. So like actionable information to help solve and fix this problem. And then also from experience, like what I've noticed is that so after you pop these bubbles, if you will, aka address these issues, and you rerun these apps for regression testing, you'll notice that if these issues were fixed, you'll see these histograms flatten over time, which is good. So in summary, I just wanted to conclude here by just saying that being able to find and fix issues with network performance is super critical in mobile apps, because the client is certainly at will of the performance of the server-side component. And that said, network performance really does correlate to one-to-one to the user experience, in the sense that there's a lot of presumptions that users already have in terms of set of expectations that users have with how an application should perform. And in order to get high reviews in the App Store, is that you need to either meet or exceed these expectations, or suffer the consequences. So that said, we built out the performance tool to address this sort of tough problem of being able to figure out what's happening at a network level when my app's running, and how do I find and fix these issues? And furthermore, how to identify these issues. So that said, from these sort of core capabilities, I wanted to wanted to walk through some of the examples. And that said, that's the sort of in summary what I wanted to show today.
Perfect. Thank you, Nathan, for very informative presentation. I think a lot of you who never been exposed to the client-side performance, I think HeadSpin is one of the kind platforms that allows us to achieve that. And if your company today is not in need for that, trust me, I work in several small and big corporations around Silicon Valley and not. And eventually, once the company goes globally, it becomes necessary. It's just unavoidable. I just look at the questions section here. I don't see anybody question, but I do have a question for you, Nathan. I'm sure a lot of folks who is watching us right now would have the same question. How's the HeadSpin actually works with test automation frameworks for iOS and Android? If you can give a quick overview how it's actually paired together, if you have some sort of script, how would you run it on the HeadSpin device farm?
Oh, great! That's an excellent question. So I'll sort of answer this in two parts. So I guess first and foremost is that everything in our platform is API driven, and this is like an intentional design choice because everyone from what we noticed from like the different customers and different developers that we worked is that even though there are common test libraries and frameworks, there's also a lot of variance in terms of how people test. So that said, everything in our platform from managing devices, like installing IPAs, installing provisioning profiles in iOS, etc., can be done via our REST APIs. But two is that we also integrate with open source test frameworks out of the box. So for instance, if you wanted to run an Espresso test, like one capability that we have in the platform is that we've created this technology we call USB over IP, such that we allow you to actually import and bridge these remote phones to your local dev machine. So you could run your Espresso test, for example, that way as well. And same can be said for XE/XE UI tests. And then in the case for Appium, since it's a client server architecture, all of the nodes in our platform are actually running an Appium server. So you as a developer have the ability to actually write Appium client-side code, point it to the remote web driver on our nodes, and actually run Appium test it if you'd like to as well on those devices as well.
Perfect. Again, I would like to thank you for very informative presentation. And I myself using the HeadSpin Tinder, but even today I've seen things that I didn't know based on this presentation. Now I know about different details. Thank you again, folks. You will receive the video recording of this presentation within 24 hours. We're also gonna send email with the video as well as our emails. In case if you have any questions about HeadSpin, you can always shoot email directly to Nathan or myself, and we'll be more than happy to jump with you, on one-on-one and answer all your questions regarding HeadSpin in case if you're interested. Thank you again, Nathan, and everyone have a wonderful the rest of the day.
All right, thank you, Igor, and thank you everyone who's part of the webinar.